In this video, we're going to talk about multiplying and dividing fractions. And to me, multiplying and dividing is actually easier than adding and subtracting fractions. When multiplying fractions, you don't have to worry about common denominators. You just multiply across the top, and you just multiply across the bottom. So if I have 2/3 times 4/5, on the top I'll get 2 times 4, which is 8, and on the bottom I'll get 3 times 5, which is 15, and I'm finished. To divide fractions, 2/3, suppose that was divided by 4/5. Recall when you divide fractions, you leave the top one alone. Write it down exactly like it was, and then you multiply it by the flip of the other fraction. So I had 4/5 to begin with, I'll have 5/4 at the end. And I could just multiply straight away. 2 times 5 is 10, 3 times 4 is 12, but this is not reduced because 2 will go into the top and the bottom. 2 will go into 10. Well, let's even write it. So 10, I can write that as 5 times 2. I can write 12 as 6 times 2. And when you see the same thing being multiplied on top by the same thing being multiplied on the bottom, you can simply cancel those things out. And again, if I reduce 10/12, I will be left with just 5/6 at the end. Okay? So dividing fractions, you're just going to flip and multiply. Notice also in this example, if I have 2/3 times 5/4, I could write 5/4 instead of 4. I can write that as 2 times 2. And again, basically, if I see something on top, I can cancel that out with the same thing on the bottom. So don't think like there's a 0 on top. Still think about there as being a times 1 on the left side. Well, 5 times 1 is 5, and then in the denominator I'm left with 3 times 2, or 6. So let's do some more examples with just some numbers in here, then we'll move on to variable expressions. Suppose I have 12 over, let's make it 25, and suppose then I have, let's make it 4 over 15. So if I want to divide these, again, I can just leave the top fraction alone, 12 over 25, and then I'll multiply that by the flip of the denominator, so 15 divided by 4. I could start multiplying straight across the top and the bottom, and then I would have to start reducing that fraction. So an easier thing to do typically is to factor it out at the very beginning. So notice I can write 12 as 4 times 3. I can write 25 as 5 times 5. I can write 15 as 3 times 5. And since there's a 4 on top, I could write 4 as 2 times 2, but since I see a 4 on top, I'm just going to leave it as 4. And okay, I see a 4 on top. I can cancel that out with the 4 in the bottom. I see a 3 on top, but I don't see any 3's in the bottom, so I can't do anything with that. However, I do see a 5 on top. I can cancel 1 5 out in the numerator with 1 5 in the denominator. I'm left with 3 times 3 on top, and I'm left with just a 5 in the denominator, and that'll be my answer. If you have more complicated expressions, suppose I have x over x plus 1 divided by, let's make it x squared minus 1 and 4x. So here's my big division sign. Again, the exact same idea. I'm going to leave the top one alone, and I'm going to multiply by the flip of the bottom. X squared minus 1 over 4 times x. Well, certainly I see that there's an x on top and an x on top that will cancel. I could just multiply things out right away, but then it would be kind of hard for me to see that things cancel. So I'm going to leave the x on top and the x plus 1. Again, recall that you can factor x squared minus 1 as x plus 1 times x minus 1. I still have my 4x in the denominator, And I can put this x plus 1, I can think about that as being in parentheses as well. So I can cancel out this x plus 1 with this x plus 1. I can cancel out this x on top with 1x on the bottom. And now I've got my answer. I'm left simply with x minus 1 in the numerator and a 4 in the denominator. And that's going to be my answer. That's now reduced. So this is the basic idea with multiplying and dividing fractions. If it's multiplication, just multiply straight across the top, straight across the bottom, but cancel things out if you can, because that'll make the resulting fraction you get in reduced form. And you'll have to do the same thing when you have these more complicated variable expressions. You still leave the top one alone, multiply it by the reciprocal, or the flip of the bottom one. And if you've forgotten how to factor some things, definitely take a look at some other of my videos. I'm going to have a lot of examples of factoring. You can go to justmathtutoring.com, and there's calculus videos at the top, there's algebra videos at the bottom. I'm definitely going to have some more examples of factoring under the algebra section. Factoring can be pretty tedious, but it's definitely one of the most fundamental things that you'll do in algebra. You'll do it just all the time with these problems. So if you're a bit rusty on it, definitely take a look at it. I hope these examples